Hey everybody, today we're going to talk about lines of best fit. Okay, so a line of fit is a line on a scatter plot that fits closely to most of the data points. It can be used to estimate the data on a graph. Your calculator uses something called linear regression to find the line of best fit. So, last time we used this data right here to create this scatter plot. Now what we want to do is we want to create a line of best fit for this. So how do you do that? It's really not very difficult with your calculator. So to create the line of best fit, the first thing you do is you push the stat key again. Okay, so your stat key is right here. And then you go to, you see these, you get this screen right here. You go next to edit, you go to calculate. And you go down to number 4, it says linear regression AX plus B. So you press 4, and it will give you this screen that says X list L1, Y list L2, and a couple other things. And then you just want to arrow down to calculate and hit enter. Okay, and what it will do is it will calculate this right here. It says y equals ax plus b. And on this one, it says a is 0.121821, and so on, and b is 75.577. Okay, so what this is this is the equation y equals ax plus b. Remember, that's the slope, or that's the slope intercept of a line. So a, the slope, is 0.1218. And B, the y-intercept, is about 75.58. So what you can do is you can push the y equals button, which is right up here in the corner. Make sure there's no equations in there. And then go ahead and plug in 0.1218. Push your X key, which is right here. It's right below the mode key. X plus 75.58 and hit enter. Okay, once you've done that, you just so it looks like this in your calculator. Then you go ahead and just hit graph again, and it will put your scatter plot back in there, but it'll also put a line through the data. So this is that line 0.1218x plus 75.58. That's the line of best fit that best fits this data. Now, it might not be a very good fit. Okay, there's ways to tell that too, but that's the line that best fits the data. Okay, so how do you tell if it's a good fit? Well, you look for something called a correlation coefficient. Now, correlation coefficient is just a number. It's between -1 and +1. The closer it is to -1, the closer you have to a negative correlation. The closer it is to +1, the closer you are to a positive correlation. If you're near 0, then there's no correlation. Okay? And you want this thing to be pretty close to either -1 or +1. So how do you calculate that? Well, you push your stat key again, and then you arrow over to tests. Okay? And then what you do is you have to arrow down to row E. Nope, not row E. It was row E on this one. Oh, it's row F. Sorry. It says linear regression t-test. Okay. So you're going to hit enter. And then all you have to do is arrow down to calculate. And hit enter. Okay, so it's going to give you a bunch of stuff on your screen right here. So here's where, I'm not sure, it's supposed to be a different version of the TI-84 that it was E, but it should be F. and you hit the F, and it gives you this screen right here, where you arrow down to calculate, and hit calculate. Then it will bring you this screen right here. And what you want to do is you want to arrow down until you see R equals. Okay, now this R equals is 0.3885. Okay, that's your correlation coefficient is R. 0.3885 is not very good. So what this is saying is this line is a very poor fit for the data. Okay, it's probably not linear. Or maybe you don't have enough data or whatever, but that line doesn't fit the data that you have very good. Now, if this was 0.98 or something, that would be a very good fit for the data, and that would be something that would be very useful to you. But what you can do, the reason that you calculate the line of best fit is because it allows you to predict. Line will allow you to predict what's coming up. So let's say this was a really good fit, and I wanted to know something that was way off the screen. Like, let's see, what were my X's here? Yeah, let's say I had something that had to go to 300 minutes, okay? I could plug 300 minutes in for X into this equation, and it would tell me 0.1218 times 300 plus 75.58 would tell me that my answer would be 112.12, which that would be my test score, okay, which doesn't make any sense because it's over 100%. So some of these things, you know, it just, you have to make the data fit. You have to have the right data. So anyway, that's how you find a line of best fit. It's pretty simple to do. You can go back through and read the directions at your own leisure. Probably best to look at them in the notes instead of on the TV screen here. Okay. So be able to calculate the R value. Remember, that's the correlation coefficient. And you want that to be near 1 or negative 1. Well, actually, you don't want it to be anything. You want to know what it is. But if it's going to be a correlation, a positive correlation, it needs to be near 1. And it needs to be pretty close to 1. You know, 0.92 or something, or higher. If it's a negative correlation, you want it to be close to negative 1. And if it's close to 0, it's not worth much. It means there's no correlation. So this table shows the worldwide movie ticket sales in billions of dollars from 2000 to 2011, where X equals 0 represents the year 2000. Use a graphing calculator to find an equation of the line of best fit. Identify and interpret the correlation coefficient. Okay, so here's what I would do. Why don't you pause the video? This is going to take you a few minutes. Enter this data. Make sure you clear the old data first. And then jump back on here and see. We'll do it together and see how you did. Okay? So take a minute to do that. Okay, so the first thing I did was I cleared all my lists. Then I go to Stat, and I go to Edit. And I go into L1, and I start putting in my data. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, now I arrow to the right. I'm now in L2, and I enter 16, 17, 20, 20, 25, 23, 26, 26, 28, 29, 32, and 33. Make sure that both of them are level so that you've got the same data in. Okay. So I've got my data in now. I'm going to go to my window. I'm going to change my window. So I want my X min to be 0. I want my X max to be, say, 15. I count by ones. I want my Y min, we'll go from 10 to 35. My Y max, we'll count by fives. Okay. Push your Y equals key. There's an equation that you have in there from the last time. Go ahead and clear that. Okay, make sure there's no equations in there. Then hit graph. Okay, I've got a scatter plot. Okay, so what does my scatter plot looks like? So it kind of looks like this. Okay, it looks pretty linear. This has more points than you have on here. I'm just trying to give you a rough idea. Okay, so next thing I want to do is I want to find the line of best fit. So I'm going to go back to stat. I'm going to go to calculate. I'm going to go to 4. That's linear regression. I'm going to arrow down to calculate again. Hit enter. And it gives me y equals ax plus b, where a equals 1.50, we'll round it to 7, and b is 16 point, we'll round it to 29. Okay, so here's what I'm going to do. I'm going to push y equals, and I'm going to push 1.507x plus 16.29, enter. I'm going to hit graph again. And sure enough, it puts a nice line right down the middle of that data. Okay? So, I'm feeling really good about this data and this line. What I'm going to do is I'm going to calculate my R value. So I'm going to push stat again. I'm going to arrow over to tests. I'm going to arrow down until I see linear regression t-test. In this calculator, it's F. Hit enter. I'm going to arrow down to calculate. Hit enter again. And I'm going to arrow down until I find the R value. It says R is 0.9818. Okay, that's a very good R value. That's a very positive correlation. Okay, so that line fits the data really well. Okay, so there you go. Now, I could use that line to predict. Okay, so I don't have, let's say, year 15 on here, and I wanted to know year 15. So what I could do is I could go 15, let's see, 1.507 times 15 plus 16.29. And that would be 38.89. So we'll round to 39. I should have about 39 billion in sales that year, if it continues to follow this. Now, that's the thing is, maybe it doesn't follow this. Usually in these books, they give you pretty good data for the time that they have. This is good data for 2000 to 2011. And maybe this continues on, except guess what we had in 2020? We had COVID, which is why my voice is sounding the way it does. Okay, boom, it killed sales. Okay, that changed everything, and this model no longer works. Okay, so you got to be aware of something like that. Okay, you only get to do 8 problems this week, so you've got 1 through 15 odd. I will see you guys later.